Hello everybody, and my name is Narendra Kumar and we are from Narendra Academy. And now we'll do activity 3, a fun activity. We are doing the chapter of light, and after that we'll do a lab activity in which we'll really make a reflection of light by a plane mirror, and we'll see how it works. So first we'll have it's very simple. Look at the figures. Look at the figures 6a and 6b. So you can just have a careful look. This figure has to come like this, inverted, like this. So how do you get these figures? That's all is the lab activity. Look at the figure 6a and 6b. Let us suppose that you've been given a plane mirror strip. So how do you get that with one you get the other figures? Place the plane mirror strip on the figure shown in such a manner that you see one of the other figures. So all the 1, 2, 3, 4, 5, 6, 7 types of shapes you have to get with one mirror. So that you can do. Take the help of your friends to complete the task. Now let's have a detailed discussion of reflection of light by plane surface. Reflection of light by plane surface, lab activity 1. Aim, verification of the laws of reflection. So the aim is verification of the laws of reflection. What are the laws of reflection? Angle of incidence is equal to angle of reflection, and angle of the incident ray, the normal and the reflected ray lie on the same plane. Required material: mirror strip, drawing board, white paper, pins, clamps, scale and pencil. Procedure: take a drawing board and fix a white paper on it with the help of clamps. So you fix it, you have these clamps in the drawing board, you fix with the help of a clamp. Draw a straight line AB at the center of the paper. So we can draw like this, straight line AB at the center of the paper, and also a normal ON to AB at point O. So you take AB and you make a point O. Draw a straight line PQ making a certain angle. So you can make a certain angle. Draw a line PQ with ON as shown in figure. So with ON, so you have to draw a normal also. You draw a normal and you make a, this is a PQ. Observe, fix 2 pins at the points P and Q vertically. So you have to fix the points P and Q vertically here. Now observe the image P dash of the pin P and Q dash of the pin Q in the mirror kept along the line AB. Fix 2 more pins R and S in such a way that they are the same line as P dash and Q dash. So this is very interesting. You go on the other side, you look there, you will find these 2 pins coming somewhere there. So you will find Q there and P there, and you put 2 more pins R and S in such a way that they coincide with P and, so it's something like this. So this will be P dash and this will be Q dash. Now we got now we can measure the angle between RS and ON. Measure the angle between RS and ON, angle of RS and ON, angle of reflection, and you will find the angle of incidence is equal to angle of reflection. So you know this angle and this angle, they will be equal. So this is I and this is R. So this is the reflected ray, so you could see it there. Repeat the experiment for different angles of incidence and measure the corresponding angles of reflection R. Is the angle of reflection equal to the angle of incidence in all cases? In which plane does the incident ray, reflected ray and the normal lie? So that now we'll discuss the plane of reflection. We have understood this. So now we'll discuss the plane of reflection. This is the next topic. Plane of reflection. Plane of reflection. In the above activity, the incident ray is the ray which passes through the points P, Q, touching the paper. The reflected ray is the ray which passes through the point R and S, touching the same paper. And ON is the normal to the mirror at point O. Do the 2 rays and the normal lie in the same plane? If yes, which is that plane? if the incident ray, reflected ray and normal are in the plane parallel to the plane of the paper, where will that plane be? Assume that the heads of all the pins pierced at points P, Q, R and S in the activity are at the same height. So we have to assume that they are at the same height. The incident ray is the ray which passes through the heads of the pins, right? So it passes through the heads of the pins, and reflected ray comes here, heads of the pins, which are located at points P and Q. And reflected ray is the ray which passes through the heads of pins which are located at points R and S. Where will the normal be? In which plane will the incident ray, reflected ray and the normal lie? The plane in which the incident ray, reflected ray and normal lie is the plane of reflection. So this is the plane of reflection. Assume that the heads of the pins which are located at the points P and Q are not of the same height. See, now he is saying not of the same height. How will the incident ray be? How will the reflected ray be? How will the normal be? How will the plane of reflection be? Arrange two pins with different heights. Arrange the incident ray, reflected ray and the normal with the help of spokes of a cycle. Then think of the plane of reflection. How does a mirror form the image of a pin or any object? So this is a very interesting activity. Don't keep it the same, and you will find there are different thing happening. Actually, if it's not in the plane of the mirror, reflection won't happen. Now we have, how does a mirror form the image of a pin or any object? Now one very important question comes. Okay, we got this experimentally. We got, okay, the image is coming here and image is coming here. But I want to know why the image is coming there. Why really? So what I really need to know is, suppose you have a mirror and you have this distance is equal to this distance. Okay. So if you keep your eye here, you will see it here. This distance, if you stand in front of the mirror, your distance to the mirror and the mirror's distance to the image inside is the same. And there is lateral inversion. Why is that happening? That is going to be the topic for our next lesson, formation of an image by a plane mirror. This is the lab activity which showed how it's formed, but now we are going to go deeper into why. This is the central deep concept. If you understand this, you have understood the whole of reflection by plane surfaces. Okay, this is Narendra Kumar. We are from Narendra Academy.